You know, for centuries, we've told these stories about the ocean's mysteries, tales of sirens, of sea monsters, and of this strange, haunting music that seemed to rise right out of the deep. But what if some of those old legends were actually picking up on a real, incredibly complex conversation happening just beneath the waves? Today, we're going to dive deep into the world of whale song, and we're going to go from ancient folklore all the way to some pretty groundbreaking science.
I mean, check this out. There's this ancient Irish folk song, Port na Bapuki, which means the music of the goblins. Legend says the melody was learned from spirits, but a much cooler theory? It was probably an Irish fisherman trying to copy the otherworldly sounds of whale song as they vibrated right through the hull of his tiny boat. It's just a beautiful idea, right? That we've been listening and trying to figure this out for a very, very long time.
But, okay, that brings up a pretty basic question. A song from a whale. We throw that word around, but what does it actually mean? How do they even make it? Is there a structure to it? And why? To get those answers, well, we have to go beneath the surface.
So first up, we need to meet the musicians and, understand their very unique instruments. Because the way whales create sound is nothing like what we do. It's really a masterclass in biological engineering. So while a lot of whales make noise, only a handful of species produce what scientists would truly call a song, with complex, structured, repeating patterns. The undisputed rock stars are the humpbacks, for sure, but blue, fin, bowhead, and even minke whales are all part of this very exclusive oceanic orchestra.
Now, what's really wild is that whales evolved two completely different toolkits for making sound. You have the toothed whales, like dolphins and belugas. They use a system up in their nasal passages to create these rapid clicks and whistles, and then they focus that sound through a fatty organ in their head called the melon. Think of it like a high-tech biological sonar. But the big singers, the baleen whales, they do something totally different. They use a unique structure in their larynx to create sound, and get this, they recycle the air inside their bodies instead of breathing out. That's the secret. That's how they create those incredibly long, deep notes that can travel for hundreds of miles.
And to really get the difference, let's look at the beluga whale. They're nicknamed the canary of the sea for a reason. These guys are super chatty. They make a huge variety of squeaks and whistles and buzzes. Researchers have found at least 34 distinct types of calls. But here's the key. These are calls, not songs. They don't have that complex, repeating, layered structure that makes a song a song. So being vocal isn't the same thing as being a composer.
All right, let's move on to the undisputed maestros of the deep, the humpback whales, and see how their music is actually built. Because when you start to break it down, the structure it's astonishing.
I mean, don't just take my word for it. Marine biologist Philip Clapham calls it probably the most complex song in the animal kingdom. And that's not an exaggeration. This is not a random collection of sounds. It's a meticulously constructed piece of music.
So the song is put together like a set of Russian dolls. At the very center, you have a unit. That's a single continuous sound, like one note. You arrange those units into a repeating sequence, and you get a phrase, kind of like a line in a poem. Then you combine those phrases, and that creates a theme, like a verse or a stanza. And finally, you string those themes together in a very specific order, and that's the complete song, which can last for up to 30 minutes, and a whale might repeat it for hours and hours.
And this right here, this shows you exactly what we're talking about. On the left, that's a spectrogram of a beluga's calls. See how it's just kind of all over the place? A chaotic mix of sounds? But on the right, that's the humpback song. Look at that structure. You can literally see the repeating phrases, the organized patterns. It's the difference between a crowd of people talking all at once and a choir singing in harmony.
Okay, but here's where it goes from just biology to something truly mind-bending. The song is a cultural phenomenon. At any given moment, all the male humpbacks in an entire ocean basin, we're talking the whole North Atlantic, are all singing the exact same song. And that song slowly changes. It evolves over the season. New phrases get added, old ones get dropped. It's like a hit song that goes viral across thousands of miles of ocean.
Now, the #1 theory has always been that these songs are for mating, a way for males to attract females or maybe compete with other guys. But that leads to this huge puzzle that's had scientists scratching their heads for years. Why do we hear them singing on their summer feeding grounds, say off the coast of Washington, when the breeding season is months away and thousands of miles to the south? It's a deep mystery, and it only gets deeper when we introduce a brand new sound to their world.
Yeah, their acoustic world, which used to be filled with only the sounds of nature, is now being flooded by a totally different kind of symphony, an industrial one. And it is causing some major interruptions.
So in some parts of the ocean, just the background noise from shipping has been going up by about 3 decibels every single decade. Now what that means is the ocean is roughly twice as loud as it was just a few decades ago. And since baleen whales talk on these same low frequencies, it's like they're trying to have a really important conversation in the middle of a rock concert. Their voices are literally being drowned out.
So what does this actually do to the song itself? Let's look at this incredible case study. Here we've got a spectrogram of a humpback whale singing off the coast of Hawaii. You see those clear, beautiful, repeating patterns? This is the whale in its element, undisturbed, just singing its song cycle.
Okay, now watch what happens when a tugboat comes chugging by. The spectrogram just gets messy. The whale's song structure completely breaks down. It becomes disorganized. He even starts throwing in new phrases he wasn't using before. Then, as the noise gets loudest, he just stops. The song, which should have gone on for another 5 minutes, is just cut short. The symphony is silenced. And here, after the boat has passed and things quiet down, look, he starts up again, going right back to his original structured song. This whole sequence gives us this clear visual proof of the disturbance. The whale didn't just sing louder to be heard. Its entire behavior, the very architecture of its masterpiece, was completely disrupted.
This all seems like a huge problem, but the very act of listening that revealed the issue is also pointing us towards solutions. By decoding these deep-sea conversations, we're actually learning how we can better protect these incredible singers.
The key piece of tech here is the hydrophone. Scientists are deploying these super-sensitive underwater microphones in marine sanctuaries and critical habitats all over the world, basically creating a network of listening posts. And this gives them an amazing year-round window into the acoustic world of whales.
And all this constant listening led to a huge breakthrough. By looking at 5 years of data from a hydrophone in Monterey Bay, researchers from Stanford and MBARI found this really striking pattern. In the summer, when the whales were busy feeding, they sang almost only at night. But when autumn came around and they started their long migration south, the singing switched almost completely to the daytime. So why does that matter? Well, it's a total game changer. Because that simple switch, from night singing to day singing, turns out to be a super reliable acoustic signal that the migration has started. We can now predict when and where huge groups of whales are going to be on the move. This could let us create a sort of whale traffic report, warning shipping lanes to slow down to prevent deadly ship strikes. It also gives us a powerful new way to track how these endangered populations are dealing with climate change, all just by listening in.
Which brings us right back to where we started. From those ancient fishermen hearing ghosts in their boats, to modern scientists decoding migration patterns from sound, we as a species are finally truly learning to listen. But it leaves us with this profound and kind of urgent question. Just as we're starting to grasp the incredible beauty and complexity of this ancient language, is our own noise drowning it out for good? Are we losing a conversation we've only just begun to understand?